Here's one more example on how we go about conducting a hypothesis test using the t-distribution. An industrial company claims that the mean pH level of the water in a nearby river is 6.8. So they're claiming that mu equals 6.8. Mu because it's about a mean. We know the statement of equality always belongs in the null hypothesis. So our claim is again in the null hypothesis. The complement of equal to 6.8 is of course not equal to 6.8. Okay, we read on and it says you randomly select 39 water samples. So n is 39, giving us our degrees of freedom equal to 38. And we measure the pH of each of those samples. The sample mean, x bar, is 6.7. The sample standard deviation, s, is 0.35. So we can tell that sigma is not known. We're using the sample standard deviation, which is why we will be in the t-distribution. Is there enough evidence to reject the company's claim at an alpha of 0.05? So here we notice, because of our alternative hypothesis, we're going to be doing a two-tailed test. So we know we've identified that sigma is not known. Therefore, we're in the t-distribution. We've got our degrees of freedom. We've stated our null and alternative. We're ready to go to our table and find our critical value. So I need to find my row in my table, 5, that says 2 tails alpha with our level of significance equal to 0.05, and then go down to 38 degrees of freedom. And you should get a critical value of 2.023. Now here, for whatever reason, I have 2.024. It's actually 2.023 in our table. And because this is a two-tailed test, then we have a critical value that is negative 2.023 and one that is positive 2.023. So now what I need to do is I need to find my test statistic, t. I need to take my x bar, which was 6.7, minus the claimed mean, which was 6.8, and divide by the standard error, which is found by taking s, 0.35, over square root n, which would be square root 39. Again, be careful about your parentheses when you plug this into your calculator. But we get a test statistic equal to negative 1.784. Well, clearly that means we're below the center of the distribution because t is negative. But our test statistic is not in that blue region, that critical region. It's actually in here somewhere. So we're in the non-rejection region. And therefore, we conclude that at the 0.05 level of significance, there is not sufficient evidence to reject the claim. And again, the claim was in the null in this case, that the mean pH is 6.8.